So here we're going to establish the derivatives of trig functions. We're not going to prove them or anything, but we're going to just establish them, and hopefully we can be convinced that these are in fact the derivatives. So I'm just going to state what they are first, and then we're going to justify them. We're not going to prove them, we're just going to justify them. So we have our derivative of sine happens to be the cosine function. The derivative of cosine happens to be the negative sine function. Okay, so we want to, these are just defined derivatives. So I'm just going to try to justify them now. Okay, so here's my sine function. I'm just going to sketch that, trace it over in red here. Okay, you can see that it is starting at 0. There's one period. I put pi over 2 over there. And I'm just going to check the slope values on this, the slopes on sine, and then I'm going to compare them to the cosine, the y values on the cosine function. Because if this is true, the slope of this function should match the y values of this function. Okay, so I'm just going to start with my 0 slope. Okay, so I have 0 slope here, I have 0 slope here. So at pi over 2, okay, I have 0 slope. Okay, so I have 0 slope there. The cosine value at pi over 2 happens to be 0. Okay, now I can also look at this point here at sine of 0. Slope of sine. Yeah, oops, I'm going to just fix that. At x equals 0, the slope value of sine through here, well, it's hard to tell. We know it's at least positive, and it happens to be slope of 1. Okay, positive 1. And if we take a look at the y value there, yeah, the y value of cosine is, in fact, positive 1. So we seem to have this match. Okay, I'm just going to go to pi. At pi here, it looks like if I'm going to say that's positive 1, I should really say that's negative 1. So at pi, I'm going to say we have negative 1 slope, and at pi, I have a negative 1 y coordinate. Okay, and then I have here pi over, I think that's 3 pi over 2. Okay, it looks like I have 0 slope here, and again, the cosine value of 3 pi over 2 is 0. So there seems to be this match. So there's nothing inconsistent about saying that the slope of sine is equal to cos. Let's take a look at the cosine value. Okay, so the cosine value, if I take a look at this cosine value, the slopes of the cosine value, well, right there, it's nice, it's 0. So when x is 0, the slope of the cosine is 0. If I look at the sine value, yeah, the sine value is 0 at that point. So it seems to be consistent with what I see up here. The slope of the cosine is equal to negative of the sine. Well, negative 0 is 0. At pi over 2, I said that that was positive 1 and negative. Well, that must be negative 1 as well. So at pi over 2, the slope of the cosine is negative 1. And the y coordinate at pi over 2 is positive 1. So they're the same but opposites. And that's what this is saying here. The slope of the cosine is the opposite of the y coordinate of the sine. Yeah, it's going to be slope is negative 1. So again, I hit the pi value. I have a 0 slope, yeah, at pi. Yeah, I have a 0 y coordinate there. All very consistent. Move on to 3 pi over 2. Okay, at 3 pi over 2, if that's negative 1, that must be slope of positive 1. And at 3 pi over 2, I have a y coordinate of the opposite of positive 1 or negative 1, which again confirms this, what I'm saying here. Okay, so although this is not by no means this is a proof, but it certainly doesn't contradict what this is saying. The slope of the sine function is cosine. The slope of the cosine function is the opposite of sine y values of sine. So there's an app that you can check out, and again, I really encourage you to visualize this. There's also a couple videos after this which will trace out the slope values on sine, and it does seem to trace out cosine, and the same with cosine. As we trace out the slope values of cosine, the slope values seem to trace out a sine function, or sorry, a negative sine function. So at this point, we're going to use these as defined derivatives. Okay, so when we see these now, we're not going to do definition, derivative, or anything. We're just going to define them as this, the derivative of sine cos, derivative of cos, negative sine.